past week in geometry, we talked about triangles, special triangle segments, and some of the important centers of triangles. In this video, we're going to talk about first some properties of triangles and then move on into the segments and the centers. So before we get started, here's a reminder of the triangle sum theorem. Anytime you have a triangle, if you take all three angles and you add them together, the angles of any triangle should always add up to 180 degrees. So all of the interior angles together should make 180 degrees. I also have a reminder here of the exterior angle theorem for triangles. And what that says is that if we have an exterior angle of the triangle, it is equal to the sum of the non-adjacent interior angles. By non-adjacent, I mean the interior angles that are not right next to the exterior angle. So this angle right over here would be the adjacent interior angle to the exterior angle. The non-adjacent interior angles would be this one and this one. They are not touching the exterior angle. They are not right next to the exterior angle. Notice if I take the two non-adjacent interior angles and I add them, 60 plus 40 is 100. They are equal to the exterior angle when I add them together. In this first example here, we're going to find the measurement of angle R, which is represented by 16x plus 2. What I have here to work with is my exterior angle, and I also have the two non-adjacent interior angles. I know from the exterior angle theorem that the exterior angle of a triangle is equal to the sum of the two non-adjacent interior angles. So 19x, minus 2. I was writing a plus 2. Plus 16x plus 2. Combining my like terms, I have 105 is equal to 19x and 16x. That is 35x. And then negative 2 and positive 2 is 0. Let me take a second and divide both sides by 35. 105 divided by 35 is 3. Now that I have my x value, I can plug in for angle R. 16 times 3 is 48, plus 2 is 50. So that is 50 degrees. And that means that this angle should be 105 minus 50, since the exterior angle is equal to the sum of the non-adjacent interior angles. So that other angle, without even plugging in, should be 55 degrees. And if you plug in, with our x value of 3, 3 times 19 is 57, minus 2 is 55 degrees. So that all works out. Find x. So I see that we have vertical angles here. And recall that vertical angles are always congruent to each other. So if this is 40 degrees, this angle here is 40 degrees. If this angle is 9x minus 2, this angle is also 9x minus 2. I also know that these two angles here form a linear pair. So if this angle is 110, this one would be 180 minus 110, or 70 degrees. I know that in any triangle, the interior angles always add up to 180 degrees. So if I add the 40-degree angle and the 9x minus 2 degree angle and the 70-degree angle, I should get 180 degrees, since all three angles of any triangle add to 180 degrees. Here I have 110 plus 9x minus 2 equals 180. That is 108 plus 9x equals to 180. Let me subtract 108 from both sides. So 180 minus 108 is 72. And then dividing by 9, I have 8. And it was just asking us to find x. So here I have answered the question and found my x value. This next question is asking us to find the biggest side of triangle BCD and the smallest side of triangle BCD. So I know that these two angles over here form a linear pair, so they're supplementary. 108 minus 105 is, oops, I did that wrong on my calculator. 180 minus 105 is 75 degrees. And now I know what all three angles in triangle BCD are. So notice how 75 degrees is the biggest angle of the three interior angles in this triangle. If this is the biggest angle, the biggest side is located opposite from the biggest angle. So the biggest side would be side BD of this triangle. Using the same idea, the smallest side would be opposite from the smallest angle. So the smallest angle in this triangle is the 50-degree angle. So the smallest side would be the side opposite, which is side BC. What we're going to do first is we're going to find all of the missing angles. So here I have triangle ABC, and I know that all three interior angles of any triangle add to 180 degrees. I'm going to add the three interior angles together, x plus 2x plus x minus 20, and that should give me 180 degrees. Here I have 4x minus 20 is equal to 180. 4x is equal to 200. So x is equal to 50. Plugging in to find the measurement of all the angles, this is x degrees, so that's 50 degrees. 50 times 2 is 100 degrees. 50 minus 20 is 30 degrees. And just verifying, 100 plus 50 plus 30 does make 180, so it all checks out. Remember, these two angles are supplementary, so 180 minus 30 gives us 150. We could have also used the exterior angle theorem for triangles to figure out what angle y was. Since the exterior angle is equal to the sum of the two non-adjacent interior angles, this angle would be equal to the sum of 50 and 100, which is 150. So if we were going to classify the triangle by its angles, I see that one angle is an obtuse angle. So this would be an obtuse triangle because its largest angle is greater than 90 degrees. The biggest side of the triangle would be opposite from the biggest angle. So opposite from the 100-degree angle is side AC. So that would be the biggest side. And I'm going to write here that's side AC. And the smallest side would be opposite from the smallest angle. The smallest angle is the 30-degree angle. So the smallest side would be across from the smallest angle. So that's side BA or AB. And we've answered all the questions here. Now we're going to talk about some special triangle segments. So I'm going to construct some of the triangle segments. Here I have an acute, an obtuse, and a right triangle. And I'm only going to do the construction on the obtuse triangle because a lot of times that's the most difficult one to do it on. But then I'll show a picture of what all of the constructions on all the different kind of triangles look like afterwards. So on the first, for the first triangle over here, I'm going to construct a perpendicular bisector of two sides of the triangle. So for a perpendicular bisector, I'm going to put my compass on one endpoint of the side that I'm bisecting. So I'm going to bisect this side first. I'm going to open up more than halfway. The exact distance doesn't matter. I'm going to make an arc below and an arc above. And then using the same distance, I'm going to go to the other endpoint of that side. Oops. And I just closed my compass by accident. And I'm going to make the same arc using the same distance. Right through those intersection points is where I'm going to draw my perpendicular bisector. I'm also going to bisect one of the other sides, so I'll draw my perpendicular bisector here as well. So let me use a different color for this so it doesn't get confusing. Let me use green for this. So I'm going to bisect this side as well. So I'm going to put my compass on one of the endpoints of that side. I'm going to open up more than halfway. Oops. but the exact length doesn't matter. Arc above and below. Oops. Going over to the other endpoint of the side, I'm going to make the exact same arc using the same distance. And right through those intersection points is where I'm going to draw my perpendicular bisector. Now, if I extend my perpendicular bisectors that I found, notice that the perpendicular bisectors for an obtuse triangle intersect outside of the triangle. That's pretty interesting. Also remember that if we made a perpendicular bisector, not only does it cut the side of the triangle in half that was bisected, but it also forms 90-degree angles where it meets the side of the triangle. Here as well, the side of the triangle was cut in half by the perpendicular bisector. It also makes 90-degree angles with the side of the triangle. Moving on to the next triangle segment, I'm going to construct the median. So remember that the median is a segment that connects the midpoint of the side of the triangle to the opposite vertex. So first I have to find the midpoint of the side of the triangle. And I'm going to do that the same way that we did here. We bisected the side of the triangle to cut it in half. So that halfway point is the midpoint. So what I'm going to start off by doing is making the perpendicular bisectors again to make the median. So same as last time, I'm going to put my compass on one endpoint of the side that I'm bisecting. I'm going to open up a little bit more than halfway. It doesn't matter the exact distance. Arc above and below. Then I'm going to go over to the other endpoint of the side that I'm bisecting. And using the same distance, I'm going to make the same arc. Right through that is where I'm going to draw my perpendicular bisector. Since this is the halfway point of the side, that's the midpoint. And in order to make my median, I'm going to use blue for the medians. I'm just going to use my straight edge to connect my midpoint. Oops, I thought that was the line. So I'm going to use my straight edge to connect my midpoint to the opposite vertex of the triangle. And there I have a median. I'm going to do the same thing on another side of the triangle. So I'll do the same other side that I did for the perpendicular bisector, this side. Once again, to make my midpoint, I'm going to make my perpendicular bisector a little more than halfway. The exact distance doesn't matter. Pick up my compass to the other endpoint. There we go. Same arc. Let me make my perpendicular bisector. That halfway point is our midpoint. And once again, I'm going to use blue for the median. So I'm just going to connect my midpoint of the side to the opposite vertex. And here I have where my medians meet, that point of intersection. And notice how it's inside the triangle. Next, I'm going to construct an angle bisector of the obtuse triangle once again. So to bisect an angle, I'm going to put my compass point on the vertex of the angle that I'm bisecting. So I'll bisect this corner angle first. I'm going to open up my compass. It doesn't matter how much. I just want to intersect the angle in two spots. Putting my compass on one of those intersection points, I'm going to open up a little more. Exact distance doesn't matter. And then over to the other intersection point. And the same arc, same distance. From the vertex through that intersection point, I have my angle bisector. An angle bisector cuts the angle into two congruent parts. It bisects or cuts the angle in half. I'll also do the bisector of this angle up here. So I'm going to take my compass and I'm going to put it, gotta turn my compass upside down to get it there. Okay, I'm going to put my compass on the vertex of the angle that I'm bisecting. Any arc, doesn't matter, just needs to hit the angle in two spots. Going over to one of those intersection points. A little bit wider, doesn't matter. An arc. Over to the other intersection point. Same arc, same distance. And once again, from the vertex of my angle through that intersection point, I have my angle bisector. Ooh, I was trying to extend it a little more and I made a crooked line. Let me try that again. There we go, a little bit better. And once again, my angle bisector cuts my angle into two equal halves. And here's the point where they intersect. Notice how it's inside the triangle. And finally, going to construct the altitude of the obtuse triangle. So to construct the altitude, my altitude is a perpendicular line that goes through the opposite vertex. So if I'm going to construct the altitude to the side of the triangle, the opposite vertex from the side of the triangle would be this vertex. So I'm going to start with my compass on that vertex. I'm going to open my compass. It doesn't matter how much. The only thing that matters is that I make an arc that hits the side of the triangle in two spots. Notice my arc only hit the triangle in one spot. So I'm going to extend this side of the triangle so I can see the point of intersection. Now I'm going to take my compass. I'm going to go over to one of those points of intersection. The exact radius doesn't matter. I'm just going to make an arc below. Let me make this a little bit smaller, else you're not going to be able to see my arc. There we go. Over to the other point of intersection. And I want to make the same arc. Oh no, they didn't meet, so I have to go extend my other one. Perfect. Right through that point of intersection, through the opposite vertex. Ooh, oh no. I thought that was my line. There we go. I got my line working. So right from the vertex with my straight edge through the intersection point, there I have my altitude. It is a perpendicular line to the triangle. You can think of it as the triangle's height, and it goes through the opposite vertex. Let me do one more altitude. So I guess I will just do the altitude to this side. So it should pass through this vertex. This would be the opposite vertex. So once again, I'm going to just make an arc. Oops, doesn't matter the distance. My arc should just pass through the side of the triangle in two spots like it does here. Going to pick up my compass, go over to one of those intersection points, make an arc, go over to the other intersection point using the same distance, and make the same arc. Through that intersection point, through the opposite vertex, is my altitude. And notice how it's perpendicular to the side of the triangle that it passes through. It's a perpendicular line through the opposite vertex. And notice how my altitudes intersect outside of the triangle. So here I have a chart that has the properties of the four special segments that we just talked about: perpendicular bisectors, angle bisectors, medians, and altitudes. So feel free to pause the video so that you can copy this down into your notes or grab a picture of it. So the point where all of the perpendicular bisectors meet is called the circumcenter. And we saw in the obtuse triangle where the perpendicular bisectors met was outside the triangle. So let me write outside. I'll just write out of the triangle. And I'll just remind you of that. For the obtuse triangle, they met outside the triangle. But notice for an acute triangle, they meet inside the triangle. And for a right triangle, the circumcenter is actually on the right triangle. So acute triangles, it's in the triangle. And for right triangles, it's on the triangle. So it's important to know where the circumcenter is located for different kinds of triangles. The angle bisector, where the angle bisectors of a triangle meet, is called the incenter. The incenter is always located in the triangle. And we saw that with the obtuse triangle, that the incenter, and I'll show you a picture again, was located in the triangle, where the incenter, where the angle bisectors meet, is located inside the triangle. And you can see for the acute and the right triangle, it's still located inside the triangle. The next one's the median. So the spot where the medians meet is called the centroid, and the centroid is always located in the triangle, just like the incenter. Where the altitudes meet is called the orthocenter, and in acute triangles, it's located outside of the triangle. Oh, sorry, inside the triangle. I'm getting confused here. For obtuse triangles, it's located outside the triangle. And for right triangles, it's located on the triangle, same as with the circumcenter. So for circumcenter and orthocenter, the location varies depending on what kind of triangle you have. Now, what's important to know about the centroid, the spot where the medians meet, is that it divides each median in a 2-to-1 ratio. So if we take a look here at this black median, this is a median because it connects midpoint to opposite vertex. If I count the spaces from the vertex to the centroid, 1, 2, 3, 4, 5. And then if I count the spaces from the centroid to the midpoint, 1, 2.5. So notice the longer part of the median is double the shorter part. So that's what I mean by a 2-to-1 ratio. The longer part is double the shorter part. Let's take a look at some examples over here. So in this diagram, we're told that CD is a median, and I know that medians connect midpoint to opposite vertex. If D is the midpoint of side AB, it cuts side AB into 2 equal parts. Quickly looking at my answer choices, I see that is answer choice number 1, that AD is congruent to BD. In the next example, we have triangle ACE, and we're told that we have 3 medians in the triangle. The length of FG is 12 centimeters. I see that FG is the shorter part of median FC. We need to find the longer part of that median GC. Well, I know the centroid, where the medians meet, splits each median in a 2-to-1 ratio. Since the 12 part is the shorter part of the median, GC is the longer part, so it should be double the shorter part. So it should be 24. Moving on to the next one, we're told that P is the centroid. The centroid is where the medians meet, so all of these segments here are medians. And we're told that BF, the whole median here, is 18. We need to find BP. BP is the longer part of the median, so we're finding the 2 part of the 2-to-1 ratio. Since we know that the whole median is equal to 18, and we know that the median is split in a 2-to-1 ratio, we can represent the 2 part of the ratio as 2x. So let me mark this in the diagram. This would be the 2x part of the ratio. And since this is the shorter part, that would be the 1 part of the ratio, or the 1x part of the ratio. If we take the 2x and the 1x part of the ratio and we put them together, we should get the whole median, 18. So here we have 3x is equal to 18. Dividing by 3 on both sides, we have the shorter part of the median. The 1x part is 6. So if the 1x part is 6, that means the 2x part is double that, or 12. Moving on to another example, we are told that L is the centroid of this triangle. So these segments here are medians. They tell us that NP is 11, ML is 10, and NL is 8. I suggest pausing the video to answer these questions over here. PO, since MP is a median, P is the midpoint of side NO. There's 2 equal parts here, so PO is also 11. We need to find the length of MP, that's a median. The longer part of the median is 10. That's the 2 part of the ratio. So the shorter part, the 1 part of the ratio, should be half of that, or 5. LQ is the shorter part of median NO. If the longer part of the median is 8, that's the 2 part of the ratio. So the shorter part of the median should be the 1 part of the ratio, or half of that. Finally, NQ. NQ is this whole median over here. That would be 8 plus 4, which is 12. And finally, we need the perimeter of triangle NLP. That would be 8 plus 5 plus 11, adding all the sides up together. 11 plus 5 is 16, plus 8, 24. Moving over to the next one, point B is the incenter. The incenter is the point where all of the angle bisectors meet. So all of these lines are angle bisectors. That means they're cutting the angles into two equal or congruent parts. If we know that FEC, so FEC, that's this whole angle, is 84, well, I already know that that means this and this are half of that. So 84 divided by 2, and that's 42. ECF, that's this whole angle here, is 28. Yes, ECF, that whole angle. 14. And we need to find BRC. So we're looking for this angle BRC right over here. So let's focus on this triangle here because we already have a lot of information about it. I know that the top angle is 42 because it was half of 84. I know that this angle here, each part was 14, but the whole thing was 28. This whole angle here is 28. So I can find the last angle in this triangle because all three interior angles of any triangle should add to 180 degrees. So if I do 84 plus 28, 112. And since all the angles of a triangle add to 180, 180 minus 12 is 68 degrees. So here we have 68 degrees. Pause the video and try the next one, see if you can get the answer. The answer to the next one is answer choice 4. We know that BF is a median, so it's splitting the side of the triangle that it's on into two equal parts because a median connects midpoint to opposite vertex. So from endpoint to the midpoint, that's one equal part. From midpoint to the other endpoint, that's another equal part. So that's AF congruent to FC. And that's answer choice 4. CF congruent to FA. Last thing I wanted to go over in this this video is finding the intersection of medians on a grid. So median connects midpoint to opposite vertex. So if I can find the midpoint of the side, all I have to do is connect the midpoint to the opposite vertex. So 1, 2, 3, 4, 5, 6. So 3 down. 1, 2, 3 would be the halfway point. That's my midpoint. I'm just going to use my straight edge to connect my midpoint to my opposite vertex over here. I can do it for the other sides as well. They're not so easy because they're not straight lines. I would need to use the midpoint formula. So for example, point C is the point 1, -1, and point A is -1, 2, 3, 4, 5, 2. Quickly using midpoint formula, I have 3. 2 plus -1 is 1. So let me find that. Oops, my bad. This is a -5, 2. This is the negative direction. My bad. So -5 plus 1 is -4 over 2 is -2. And this doesn't change. It's still 1/2. So I have -2 and then halfway between that. So -2 and then 1/2. There we go. And then using my straight edge, I would just connect the midpoint. Oops, this as accurately as possible. Midpoint to opposite vertex. And then I can see the intersection point. I can do the other side of the triangle to be even more precise, but I already can see the intersection point. And I see that it is the point -1, too.